Right, hello. I just want to talk briefly on, give a very summary of various questions on this particular exam paper. I don't want to go into every question in detail. In fact, I'll only be talking about half the questions on the paper anyway. But if you wanted to get the full model answers for the questions I'm talking about, you can go to this website, and there's also a link on that website to get to download the exam paper itself. Right. So yeah, I'm sorry about some of the writing on these exam papers, but yeah. So here we have a question of logarithms. Yeah, just bear with me a second. Yeah. Okay, so I keep repeating myself as I do these videos. I keep repeating myself a lot of times, but as I've said before on previous occasions, what my recommendation here is that you move all the log terms onto the left hand side, and then everything else on the right hand side. So what we've got log, log 2 x plus 3 plus log 2 x plus 10 minus 2 log x equals 2. And then just process that. So that's log 2 now that's over x squared. Okay, so that is actually minus log x squared using the standard rules. So I'll just put that straight in. Just for brevity, you might want to add an extra line in when you're actually doing this in practice. But I'm trying to save time here. So yeah, so that's once it's like that, all you have to do then is just anti-log both sides. That just becomes that expression. And that just becomes 2 to the power 2, i.e. 4. And then you can proceed from there. Now, the next bit is just processing it as a quadratic equation and so on. And then it says, hence state which of the roots in part bi, i.e. this one here, is not a solution of this. So this, you've derived that from this equation at the top here. Now this is when, it says here, giving a reason for your answer. This is where some lovely situation always arises, when people have to write something down in English, and it just becomes commonly just a complete mess, And on top of this, probably related to this, but here, people commonly getting the wrong answer. Probably what they meant to say was correct, but it didn't actually come out that way on the paper. I mean, the essential thing is that you have, I should say that one of the roots of the quadratic equation up there was you had minus 5 over 3, and then you had 6. Why is one of these not one of the required roots? Well, it's basically this one here, and the answer is that you cannot take the logarithm of a negative number. That's all you need to put down. What's the reason? The reason is that you cannot take the logarithm of a negative number. What a considerably large number of people put down saying you cannot have a negative logarithm. And that is incorrect. You can have a negative logarithm. You know, the logarithm of a number less than 1 will be a negative number. So you can have a negative logarithm, but you cannot have the logarithm of a negative number, which is something completely different. So, you know, a lot of people are losing marks there, presumably, I hope, just for sloppy English rather than actually because they didn't understand the mathematics. Right, this one I'm not too sure I want to say anything too much about this. This is yeah, this is fairly straightforward. Bit of integration and a bit of differentiation and integration. The one thing I probably should say is that sorry. It says the curve C has equation such and such. So when you actually, on a later part, when you need to find the integrate, what you do, if it's good practice, you don't put C down as the arbitrary constant in the integration. You choose some other letter. So that's just sort of a note on good practice. Right, again, this is it's done fairly straightforward as far as I can remember. You know, there's mostly I don't think there's anything particularly to note about it. I mean, I just stress the method. If you're going to differentiate that, then you can use implicit differentiation. So that would become 3x squared plus 2x dy by dx plus 2y plus 6y dy by dx equals 0. Yeah, there's well, I'm trying to think about this. There was it's caught me a bit on hop here. I think there was a bit of a problem commonly with people who didn't put the 0 down or something like this. But that's the differentiation anyway. And then you group the dy by dx's together. Dy by dx 2x plus 6y, and then send everything else over to the other side. So that's minus 3x squared minus 2y. So therefore dy by dx equals right. This next bit, again, this is quite a common question, so my remarks will probably be the same as I mentioned before. It says find the point lies on the curve, find the equation of the normal. So you've got dy by dx from, I've just calculated dy by dx just now, so that'll enable you to give the gradient of the tangent, which I can tell you is minus 11 over 13. Okay, so that's the gradient. Gradient of the tangent at that point using dy by dx, which you've just calculated in A. So the gradient of the normal, again, you know, you need to sort of write it out in full rather than just saying. You can imagine the sort of brief remarks that some people make, if any at all, you know, just to differentiate from the gradient of the tangent from the gradient of the normal, just to tell the examiner what you're doing. So the gradient of the normal will be 13 over 11. And the point is minus 2, 5. So the way I always recommend drawing up the equation is to say y, well, for this particular point, y minus 5 equals the gradient, 13 over 11, x minus 2, which is x plus 2. Okay, as I've always said a couple of times before, you know, some people write down y equals mx plus c, stick the relevant values in, and therefore calculate the c out that way. But I just find it more logical to do it this way. So, again, some people might do it this way and then start expanding this bracket. Well, my recommendation is to just get rid of the denominator and then just make things easier, just make the arithmetic easier for yourself and more transparent for the examiner. It's a good general practice, hint in practice really, hint in general really, to try and get rid of the denominator when you've got one. You know, I mean, obviously it's not going to work in every single case, but in this case, get rid of the denominator. That's the way I would definitely recommend. Well, I'll just do this in one go as well. I'll set the denominator across, and then I'll multiply the bracket out. Like that. And one final point is, if you can see this on your screen, it says, giving your answer in the form ax plus by plus c equals 0. Now it says quite clearly that you need the form you need to give the answer in. And it's surprising, nevertheless, the number of people who do not give it in this form. Well, it's two things really. It's asking you to put everything over on the left-hand side. That's the first thing. So if you know, some people will stick things on the right-hand side, nevertheless. But it's asking you specifically to put everything over on the left-hand side, and then it's saying A, B, and C are integers. So again, you know, it's surprising how many people would stick everything over on the left-hand side, but then still have A and or B or whatever as fractions. So, you know, points being lost there just because people can't read the question properly. Right, this one's, I'm afraid this printout is a bit of a mess. But we've got a standard message here of 2 yeah, this is a standard procedure. Again, my possible criticism of this is people don't really put down full enough comments to, you know, to explain what they're doing. I mean, what are you going to do here? You've got, well, I'll do the procedure anyway, just to, while we're on the question. So that's equal to that, but what I'm going to do is I'm going to equal cosine. I'm going to expand that out. Oh, actually, yeah, cosine theta. I'm going to get this all on here. Right. Yeah. Okay, so you're actually given the form there. What I was going to say, thinking of doing originally was just making a few points on what form you would choose if you weren't given it. But basically, to my mind, you choose this form, i.e. the plus or the minus. You choose it as to where the signs link up here. Okay, so you choose the minus sign specifically so that when it's expanded out, you've got a plus sign and a plus sign there. So you can just make the straightforward connection. You know, I can just now say that R r cos theta it corresponds to r con alpha corresponds to this one here, so that's equal to 2, and r sine alpha that's corresponding to that one, so that means that r sine alpha equals 8. And from there you square, well, if you divide one by the other, i.e. the other way up, you'll get tan alpha equals 4. So that will give you the enable to find out what that alpha is. And then you square both of them and then add them together. And the cosine squared alpha plus the sine squared alpha will go to 1 by the standard identity. So you get r squared equals 2 squared plus 8 squared. And eventually 64, 60, yeah, so it's the square root of 68, which is 217. Okay, so I myself have done it in a bit of short form, but I prefer it actually, if you're doing it, to do it specifically, state specifically what you're doing, you know, square both sides, such and such, divide one by the such and such, and that drops the answer, which you, for your information, the answer, that's 2 out of 17, so that goes the r, and you've got your alpha, which is the tan, corresponding to tan to minus 1,4, which is 1.326, because we're using radians. Now, it then goes on to talk about it gives me an arithmetic sequence like this, and then says find the exact value of Sn, i.e. sum of 9 terms, deduce the smallest positive value of x at which this maximum value of S9 occurs. Now what the major feature is that people seem to be unable to make the connection with this part B with what we've done on part A. Right, sorry, this is a bit confusing here. It's cosine x, and then the common difference all the time is sine x. So that's the sequence there. So the formula would be Sn equals NO2 2a plus n minus 1 d. So that equals 902 2 cos x, okay, 2 times that, plus 8, the common difference, which as I said, we just said is sine x. Right, so that's what I've said really, that people could derive this possibly, but then the unable to make the connection between this inside the bracket and this expression here, which is quite amazing. So you use that expression to reduce it down to this form, which you've already calculated, and that'll make things easier for yourself. By doing that, you'll get up to, because I've got the figures at hand, you've got 9 over 2, that was, did I just give you that? Yeah, I just gave you that before, so it's 2 over 17 cos x minus 1.326, which equals 9 root 17 cos x minus 1.326. Right. So it says deduce the smallest possible value of x at which this maximum value of S9 occurs. Well, sorry, I'm getting ahead of myself here because that's not the actual answer, is it? I'm looking for the maximum value of S9. So I need the maximum value of this. And the maximum value of this is when cosine is 1. So that the actual answer is 9 over 7. Maximum value is 917. And then it goes on to say, deduce the smallest positive value of x at which this maximum value occurs. Well, I mean, it's got to equal 1 when this is 0. So x minus 1.326 equals 0 implies that x equals, the required answer is x equals 1.326. That is the smallest positive value of x at which this maximum value occurs. Yeah. So as I say, that part B especially was actually done quite badly. Again, I'm sorry about this markings on these papers. If you can ignore the red marking. This was done quite badly as well. So what it's saying initially is, well, that's what it's showing initially. Show that dH over dt equals lambda over h. Right, so if you're a bit clueless as to where to start on these, you can always put down what you're given, you know, the information you're given in the question, then have a look at it and see where you can go any further. So it says here that the rate of change of v is inversely proportional to the square root of h. So dv over dt is proportional to 1 over h. That's what it's saying in the question, and that implies that dv over dt equals some constant over h. And we're also told that, well, V, I should say, is, did it say here, V is the volume of the water, not the yeah, the volume in the water is V, not the, so it relates to the volume of the water, not the size of the tank. So V is 200H. Okay, so I can go from there and say, okay, if we know what that is, then I can work out what dV over dH is, and that's 200. So that's what I've been able to do. What do I need? Well, I need this one here. I need dH over dt. So have I got enough information there? Well, basically I have. If you can recognise what you've got, I've got that and that. So I could say, okay, that's the dt there. That's okay. Sorry, equals dv over dt. But if I enter that in the inverse form, dH over dV, that is mathematically correct. Okay, that's okay. It's just like a fraction, really. You treat that as a fraction, that will cancel out, and that's dH over dt. And that's what I've got. I've got the VOT, which is k over root h, and that is that. So it's 200. So the only thing I need to do now is setting. Need to actually write it down. Well, to my mind, you need to set it down. Setting lambda equal to k over 200. That then becomes dh over dt equals lambda over square root of h, which is what I'm after. Now the next bit asks you to it says use the model to find an equation linking h with t, giving your answer in the form such and such. Now, what some people did. Can I find my paper again? What you need to do is start off with this equation here. That's the equation you're given in the question, so it seems logical to start off from there. What some people did was start off with something like this. They might have said in the part A, they might have said, okay, just since k over 200 is a constant, that equation is derived, or something loosely like that, in such a manner that when they started doing part B, they started off from this form here, and that's not incorrect. It's just that you're replacing one constant with two constants really, and you're just making the arithmetic a bit more messy. So you don't need to do that. You start off from here. And then you separate separate the variables out, so you end up with h dh equals square root. Right, yeah, sorry, square root there as well. So the next step is quite crucial actually, which the next step is 2/3 h3 over 2 equals lambda t plus c. And it needs to be stressed here that there is an arbitrary constant. You could have put it on the other side if you wanted to, but there needs to be an arbitrary constant in this procedure. The fact is that you're trying to derive this. You're trying to derive this where a and b need to be found. So that's what you've got here. You've got two constants. You've got lambda and c, which are your two constants. You're given two sets of initial conditions, which you put in separately to find out what lambda and c are, and then this form of answer will drop out. What's going to happen if you miss this c out? Then you're not going to be able to get the work out both of the arbitrary constants. And that would be quite disastrous actually, because there's 5 marks for this question, I think. Yeah, there's 5 marks for this question, and if you miss that out, if you miss the arbitrary constant out, the most you could get is 2. So it needs to be stressed here. Stick the arbitrary constant in, and there's just a little bit on the end here. It says hence find the time taken from when the water started flowing into the tank for the tank to be completely full. Again, that's in terms of minutes. So I mean, for what it's worth, it's 18.4 minutes, and you could stick that down as. Actually, that needed to be right. 18.4. Oh, sorry, yeah, it's 18.4 hours, I think. Yeah. Yeah, the little thing I was going to stress here is that you could put that down in minutes. You could say, okay, 18 hours, 25 minutes. I mean, first off, you do need to stick the units in. You can't just stick down 18.4 or something like that. You're going to lose marks if you don't stick the units in. But stick the units in the correct way. Minutes is MIN. You don't use M because M stands for meters. And it's, right at the beginning of the question, they did actually use M for meters anyway. So you need to use a separate thing for minutes. So 3 letters is allowed, MIN. But for the hours, that goes back to the original convention. You just use 1 letter. Traditionally in units, you either just use 1 letter or 2 letters, and for the most part it's just 1 letter. Sorry, for the most part it's 2 letters, I should say. It's 1 letter for the base units like meters and seconds and grams and so on. But yeah, hours, given it that in one, it's like common in everyday life. It's commonly misused. Kilometers per hour. Kilometers per hour is like that. Okay, that's the correct way. So you can give your friends a bit of stick if they should try putting it down in the incorrect method. This is the mathematical way. Right, so this is integration. What can I say about this? Well, it starts off with the binomial theorem. Now this binomial this expression needs to be modified before we can use the binomial system. If it was an integer, if it was a positive integer, you could just expand it straight away. But because you've got a negative integer, you need to modify it such that the first number inside the bracket that you're going to end up with will be a 1, and the second term will be less than an expression less than 1. So here you've got 3 plus x minus 2, so that's equal to 3, 1 plus x over 3 minus 2, which equals 3 minus 2, 1 plus x over 3 minus 2. So that's what we've got. Again, 3 minus 2 is 1 over 9 if you wanted to. But we're going to expand that now. So that's the first number is a 1, and this will have a magnitude of less than 1. So we can then expand that in the normal way. Yeah, so I don't think I need to say anything special about that. Part B, yeah. Again, this is fairly straightforward, but it seems to catch a lot of people out in certain ways. I mean, you're just going to use the expression you derived in the first bit and then multiply it by 6x. It's, well, what you got in the first bit was the expansion was 9 over 2 over 27 x plus 1 over 27 x squared. So that's what you got from the first bit. So the this is now just going to be that multiplied by 6x. So you can simplify that and then integrate that. For some reason, I don't know, I need to say things here which most people probably realise anyway, but I need to sort of mention things which are common errors. A common error was for people to put that in the denominator, have 6x over that. They think that's because they've got a denominator there, they need to put the expression from a into the denominator. But I mean, that's just not true, is it? Do I need to explain that? You take the expansion from a and just multiply it by 6x to get the required expression to be integrated. Now it then tells you to do it in the normal analytic way. I won't do every way here because there are in fact 3 separate ways which are perfectly acceptable. You could substitute and say, okay, let u equal 3 plus x, and that implies that du over dx equals 1, and that will give you enough to substitute it properly. So you'll get so the integral goes to, again, I'm writing this in short here. When you're writing it down yourself, you probably recommend you do it in a more explicit way. So you can stick the full integral and let's say it equals to, it becomes 6 u minus 3 over u squared du. Yep, are you okay with that? And in order to integrate that, you need to separate it out. So leave 1 over u minus 3 over u squared du. Go from there. So that'll give you your log term, because it does mention in the question that one of the answers is going to be a log. You could also do it by partial fractions, saying that 1 over 6x 3 plus x squared equals a 3 plus x plus b and you can do it that way, or you could do it by parts, and you could say, okay, 6 3 plus x squared equals minus 6x over 3 plus x over minus 6 over 3 plus x dx. So I've got, again, people remember integration by parts by different methods. The way I would remember it is to say, okay, I've got one bit that stays the same while the other is integrated. So that's what I've got here. And then the part that's integrated goes into the second bit, and the one that stayed the same here is differentiated. So that's what I've got here. Now you can see what I've got here now is I've ended up with an integral that can be integrated straight away. I mean, I could say a few things about integration by parts, but I'll leave that till a more appropriate time, I think. I think the essence I want to say is that some people just stroll into integration by parts just because they can't think of any other way to do it. But there is a method there is a reasoning behind integration by parts. You know, you want to end up with an integral that you can integrate at the end of the day. And some expressions, you know from the beginning that you won't be able to do that, so it's not appropriate to use integration by parts. So if you're going to use integration by parts, at least be aware that what you want at the end of the day is an integral that you can actually integrate straight off, and see if that's compatible with what you're trying to do, the integral that you're trying to do at the beginning. Yeah, it's a bit needs a bit of thought as the method behind this but yeah, it's quite a legitimate way to do that as well. So anyway, that's your lot, and as always, thanks very much if you're still with me at this stage, and cheers for now.